So, ladies and gentlemen, great thing about today's lesson is we've already actually talked a little bit about it. We talked about using our multiplication chart to find equivalent fractions. So, who wants to give me a fraction? Give me a fraction, any fraction. Looking for a fraction. Yes, Caitlin. 2/4. Okay. So, what I will do is I will work with either vertical rows or horizontal rows. 2 and 4. Or 2 and 4. And what I'm going to do is I'm going to have a ton of equivalent fractions. 2/4 is equal to
4/6. 6/12. 8/16.
Oh, isn't that neat what it is?
10/20, exactly. Okay? Right, so on and so forth. So, be a 0, Nero. So this is how we can use a multiplication chart to find equivalent fractions. Why don't you go ahead and get out your multiplication chart and we will try it.
And guys, if you need to do a light circle, like Mr. Adamson did with a pencil, go for it. Okay? But remember, you have to use it. What?
So Tanner, how can you not have something that we talked about having before recess and lunch?
I had it.
Or if you're on page 7 in your math workbook, I'm not going here, fifth graders. Take a peek. There's a sample of one. It says you can use the multiplication tables to find equivalent fractions. Who wants to read question 1 for us? Go ahead, Kendra. Page 7 of your math workbook, question 1. Well, you can have multiple things out at once, right? Okay. Yep, page 7, question 1, please. Okay, so if you want, kind of give a circle on the first multiplication chart. Circle the 4s and the 9s.
All of them?
In your math workbook.
Oh.
Circle the 4 row. 2 and the 9 row. I turn that off, and I'm going to turn on I'm going to project our work page.
Either way. Mr. Adamson, incorrect. They can do either way, right?
Horizontal or vertical?
Yeah,
Absolutely.
horizontal or vertical.
Yep.
Either way is correct.
Okay, so this is what we should all be looking at. If you're not looking at this, please find this. It's on page 7 in your math workbook. I was asked to circle, so we're either going to do 4 and 9. Now, we're not going to write 4/9 again because that seems kind of silly. We don't need to write 4/9 is equal to 4/9. Yes, it is, but what would be our first equivalent fraction if we look, if we're moving to the right on our multiplication chart? Felicia. Awesome. You're also going to give me an answer. So here we have 4/9. Take one step over. Are you in your math workbook? Yes, you are. Awesome. So if we, 8/18. Awesome. There it is. 8/18. Who can give us the next equivalent fraction? Kendall.
12, 17, 12, 27.
Awesome. Who can give me the next one? Madison.
16, 36.
Excellent. Who can give me the next one? Tariana.
20, wait.
Yep. 20/45. Who can give me the next one? Go ahead,
What is it? 24?
Miss Kissinger.
24.
Okay, who can give me the next one? Abby. 28 63rds, right? So we're on 28. Go straight down to the 9 number, 63rds. Who can give me the next equivalent fraction? Riley.
32, 72.
Yep. 32 70-seconds. Yep. After 32 70-seconds,
Huh? I got mixed up. I did 36 and 81.
36 81st.
Now, Mr. Adamson, what is a good way to remember? Okay, what if I can't use the? I have to go in a specific order from like least to greatest for my fraction, right?
Well, here's the deal. Could I have mixed all these up? Absolutely, because equal means equal. But the point is, I think it's great to do it in order, so that way you don't get lost or confused.
But what about, does the top number always have to be the smaller number?
Well, if it starts that way, absolutely. If you start with what's called a proper fraction, where you have 4/9, 4/9 is less than a whole, I would certainly hope that every other fraction you write as being equivalent or equal would also be less than a whole. We can't just go, oh, let's do 90/40ths. We can't do 90/40ths next because that's a lot bigger than a whole. That's saying you had pizzas cut into 40 slices and you had 90 of those slices. That means you have over 2 whole pizzas, actually.
So most likely, if it starts out with a smaller number on top, it's gonna stay with a smaller number on top for the rest of your fractions, you're saying, huh?
So, well, here's my question. If I went and bought each of you a candy bar, and I gave each of you one of these amounts, would anyone be getting more than somebody else?
No. Wait.
Yeah.
What? It's the same.
Yes.
Okay, let's back up the boat and get on that train for a little bit, please, because we need to make sure we're understanding this. If I take a candy bar, cut it into 9 pieces, and give Adonis 4 of those pieces, and I take that same size candy bar, and I cut it up into 45 pieces, and I give 20 of them to Jessica, did Jessica and Adonis get the same amount of candy?
Yeah.
Yes. Jessica's just gonna have a lot more smaller pieces. But if we put all those pieces together, it's gonna be the same size as if Adonis put all of his pieces together. That's why they're called equivalent fractions.
It's just like what Mr. Adamson said about his grandpa. His grandpa, the story that he remembers is getting 2 pizzas, same exact size, but he's like, okay, do we want them in slices like this, or do you want them in like squares? And is the pizzas changing? No. the same exact size, but you're just gonna get a different little squares instead of a big slice, right?
As long as we're starting with the same whole, which we're talking about 1. 1 is the whole. We're not attaching anything to it. We're not talking cookies, pies, pizzas. 1. Just the number 1. So if you have 8/18ths of 1 whole, it's the same as 28/63 of 1 whole. They're equivalent fractions. Does anybody notice a pattern with what's happening on the top and a pattern on what's happening with the bottom as we move from left to right? Are you seeing a pattern, Kendra? Yeah, and the bottom goes by 9s. So let's skip count, or let's count by 4s together. 4, 8, 12, 16. Wow, if this is together, I'd hate to see separate, right? Let's count by 4s together. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Hopefully you notice that same pattern right up here. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. That's why I think if you keep them in order, it's going to help, because you can go, whoa, that's not the order. Look at this. 9, 9, 18, 18, 27, 27. Okay? It's a pattern. Now it's saying, what is number 2 asking us to do? What is question 2 or problem 2 asking us to do? Chase.
Color rows 3 and 8 in the second table.
Okay. So 3.
The table complete with equivalent fractions of 3 8.
Okay. So I'm just going to kind of write numbers next to it. First fraction, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th fraction. So there you did the first fraction for us, right? The first fraction is 3/8. What comes next? What's our second fraction? Well, look at where number 2 is. 6/16. Maybe it'll help if I give these a little highlight. Hopefully it'll show up still. Yeah, kind of. Should have used yellow. Sorry. Let's see if I can make it work. Hey, there it goes. So, to me it's pretty glaringly obvious now. What's our next, if we, oops, let me zoom out a little bit so we can see the problem. So we just did 6/16. In row 3, what is our next equivalent fraction? On Hale, what's going to be our next equivalent fraction? 9/24. Awesome job. The only extra chatter I should hear is Mr. Lencher maybe trying to help explain it to somebody else. What's our next? Let's just go up and down the rows. Tariana, what's our next equivalent fraction?
12/13.
Abby, what's our next equivalent fraction?
15/40.
15/40. Okay. Let's make sure we're caught up. Let's make sure everybody's caught up. Kayla, what's our... Not Kayla. Michaela. Michaela, what's our next equivalent? So we just did this one. Kendall, why don't you move up to this spot, okay, please? So what's our next two highlighted numbers? We just did 15 40ths. Did you have these circled in your book or no? I would have the 3 and the 8 columns circled. Do you? Do you have the 3 and the 8 circled? The columns? Okay. Let's not get caught up on how we're going to label it or like pronounce it. Just say 18 over 48. That works. What's our next one there, Adriana?
21 over
56. What's our next one, Paige? Good. What's our next one? Roller skater? Sorry, rollerblader? 27 over 72. Good job, Melody. Great answer. On Hale, what's the last one?
38.
Yep. Yeah, I got you. 30 over 80. 30 80ths. Okay? That's how we use a multiplication chart to find equivalent fractions. That's not new. We talked about it actually last week. I know we pulled out our multiplication charts. I'm going to have you do problems 3 and 4. Do problems 3 and 4 by yourself. Now remember, it's saying to do equivalent fractions. So if it says 1/4, what does that mean? We're going to look at the 1. We're going to look at the 4.
Guys, can you please be quiet?
So go ahead, take a few moments.